Have you ever stopped to think about what actually happens in that split second after you hit enter on a prompt for an AI? I mean, it really does feel like magic, right? But it's not. It's a fascinating step-by-step journey. So today, we're going to pull back the curtain and follow your words from the moment you type them all the way to a fully formed AI response.
All right, let's get right into it. You've just typed your question. To you and me, it's just text, human language. But here's the thing. An AI doesn't see words, it sees math. So the big question is, how on earth does it translate your thoughts into numbers it can actually work with? Well, that's the mystery we're going to solve right now.
So this whole trip happens in four main stages. First, your sentence gets shattered into little pieces in a process called tokenization. Then, those little pieces are turned into these long lists of numbers through something called embedding. After that, the AI does what's called inference to figure out the relationships and the hidden meaning in your prompt. And finally, it uses all that understanding to start predicting the response, one word at a time. Think of this as our roadmap for the journey.
Okay, let's start with stage one. The first thing you've got to understand is that these machine learning models are basically just gigantic mathematical engines. They can't just, read text like we do. Your words have to be converted into a format the machine can actually compute. And that very first step is called tokenization. This is how the AI builds its entire vocabulary. Now, instead of just splitting sentences by spaces, which would create a ridiculously huge dictionary, modern AIs are way smarter. They break words down into smaller, much more common chunks called tokens. And this is what makes it so clever. Take a word like unbelievable. It gets broken down into its building blocks: un, believe, and able. By doing this, the AI can figure out new or rare words it's maybe never even seen before. It just pieces together the meaning from the parts it already knows, which makes it incredibly flexible. Okay, so we've got our tokens, but they're still just, pieces of text. The next step, and you could argue this is the most important one, is to give them actual mathematical meaning. Let's see how the AI pulls that off. This is done with something called a vector embedding. Now, think of it like this. Every single token the AI knows gets its own unique set of coordinates. But we're not talking about a simple 2D or 3D map that we're used to. Oh no. We are talking about a conceptual space with hundreds, sometimes even thousands of dimensions. And that giant list of coordinates, that's the token's vector. So you might be asking, where do these coordinates even come from? Well, the AI uses a massive lookup table. For every single unique token ID, there's a corresponding vector just stored in the model's memory. So when your prompt gets tokenized, the AI just looks up the vector for each token. For a model like GPT-2, this table has over 50,000 tokens, each with its own personal vector. And this is what one of those vectors actually looks like, just a long list of decimal numbers. Now, each number represents some different feature or aspect of that word's meaning. We can't really put a label on what each number means, like, is this one animacy or size or furriness? We don't know. The model just learns all these complex relationships automatically while it's being trained. And this is where it gets really cool. All these vectors, with their hundreds of dimensions, they all come together to create an unbelievably detailed map of language itself, a map of meaning. And you can really see the structure of that map here. Just like cities on a real map, words with similar meanings are located close to each other. So all the vectors for animals, cat, dog, kitten, they'll all huddle together in one region. Meanwhile, apple and orange will be in another cluster, way over here. The distance and the direction between these vectors, that's what represents their relationship. This map is so incredibly precise, we can actually do arithmetic with concepts. Get this, if you take the vector for king, subtract the vector for man, and then add the vector for woman, the point you end up at in this crazy high-dimensional space is right next to the vector for queen. This proves the AI has captured really complex ideas like gender and royalty just from reading text. I mean, isn't that wild? So how does the AI actually measure this closeness? It's not about the straight line distance between the points. It's all about direction. Using a method called cosine similarity, the AI looks at the angle between two word vectors. If they're pointing in roughly the same direction, the AI knows their meanings are super related. So let's take a breath.
The AI has tokenized your prompt and mapped it into this rich, crazy space of meaning. It gets the context. Now it has one and only one job to do: figure out what comes next.
At its heart, a large language model is really just a very, very sophisticated autocomplete. Seriously. It's been trained on billions of sentences from all over the internet, and through all that training, it's learned the statistical patterns of how we use language. It has learned that after the sequence, Mary had a little, the token for lamb is, by a huge margin, the most statistically likely word to come next. And the whole response is built just one piece at a time. The AI predicts the most probable next token, tacks it onto the sequence, and then, and this is the key part, it feeds that new, slightly longer sequence right back into itself to predict the next token. And this loop just goes on, token by token, until it decides to stop.
But this process, this constant game of predicting the most likely next word, it has a fascinating and, let's be honest, sometimes really problematic side effect. It leads to these moments when the AI just confidently makes things up.
And this is what we call an AI hallucination. It's an answer that sounds perfectly reasonable, it's delivered with complete confidence, but it's just plain wrong. It might invent a fact out of thin air, twist a detail, or even give you a link to a website that doesn't exist.
So how common is this? Well, it's probably more common than you think. A study from the Columbia Journalism Review found that when they asked ChatGPT to source 200 real quotes, it just flat out made up the source 76% of the time. And here's the kicker: it was confident almost every single time. And this brings us to the most crucial point. The AI isn't lying to you because it doesn't even have a concept of truth. Its fundamental goal is not to be accurate. Its goal is to be plausible. It's just trying to generate the sequence of words that seems most statistically likely to follow your prompt, based on all the data it's learned from. This means hallucinations aren't a bug that can be fixed. They are an inherent feature of how this technology works. It's just the natural result of a system that was built to be a master pattern matcher, not a fact checker. So, let's do a quick recap of the whole journey. Your prompt is broken into tokens. Those tokens are converted into numerical vectors. Those vectors get placed on a giant map of meaning, which lets the AI understand context. And finally, the AI uses that understanding to play a prediction game, generating its response one probable token at a time. And all of this brings us to a really important final thought. The very design of these powerful AIs prioritizes making sense over being factually correct. So as we build these tools more and more into our daily lives, the really critical question we all have to ask ourselves is this: how do we navigate a world that relies on a tool designed to be plausible, but not always truthful?